morning. My name is Ken Sweeney, and I am Chief Engineer of AIT Bridges. And I'd like to start by going over this outline, and this is what I plan to present today. Grist Mill Bridge, Twin Bridge, and Sun Island. Pretty much a little bit of information about them and a little bit of case study, design considerations, the manufacturing process, utilization considerations and unique applications, and then the future of FRP girders. Grist Mill Bridge was a celebration for the completion of the project was May 21st of this year, and this is really the first bridge of its kind utilizing the G-beam system, and it was very successful. And I'd like to first of all congratulate the University of Maine, as well as the Transportation Infrastructure Durability Center and Maine DOT for their work in advancing this new technology. Let's talk a little bit about Grist Mill Bridge, and certainly there was a lot of research and development went in before we started down the road of this first pilot project. As you can see, the girder on the left-hand side of the screen, and then the completed fabrication in our shop here in Brewer, Maine, and then installation at the bridge, and then finally load testing by the University of Maine and Maine DOT. The live load test was very successful, and it led DOT to continue to use these new girders and this new technology. Next. So the next bridge I wanted to talk about was the second bridge, which is also in Hamden, Maine. It's twin bridge replacement, and it will be constructed this fall. It's under fabrication right now in our shop, and due to be delivered and set in place and open to traffic prior to winter. The span is 53 feet. The depth of the girders are 20 inches, and it's 6 G-beams, FRP G-beams. We partnered with WSP Consultant Engineers, and the contractor is CPM Construction. This is different than the Grist Mill Bridge. Grist Mill was a cast-in-place deck. This is a precast partial deck, 4-inch partial deck. And then it also will have a cast-in-place deck on top of it. Quite a few advantages to using this modularization concept. And so there'll be modules. They're 53 feet long. And a traditional solution to this project would have been using a next beam, Next 24F, and the weight of that would be 53. Versus the G-beam of 32. After that, we began working with the University of Maine to develop a different system. This system is using as you can see, the teeth, the ridges, and along with bolts, but the bolts are spaced further apart and provide redundancy. But the primary load is carried by the teeth. So you can see that that was adding quite a bit of efficiency and also some structural redundancy to the system. The other advantage, the other piece that has changed since Grist Mill was we developed a fabric that we could put multiple layers and stitch the multiple layers together and have less labor involved with laying up the bottom flanges of these girders, which are quite thick, on the range of 1.5 inches, and some of the designs we've seen as much as 2.25 inches thick. And that's the main tension carrying part of the girder. Talk a little bit about the manufacturing process. It's a vacuum infusion process. We use a steel mold. Grist Mill was a wood mold. We've since moved to the steel mold, which gives us added efficiency and also a lot more multiple reuses. And the glass fiber and carbon fiber reinforcements are layered into the mold, and then it's bagged, a vacuum drawn, and then a fusion is done with a thermoset resin. Once cured, you pull it out of the mold. You drill your holes for the shear bolts, and we're also doing testing right now to replace stainless steel shear bolts with composite shear bolts. And those are presently under development, as well as we've done some fatigue test. University has done some fatigue testing, and we'll do some more. So the next project I want to talk about was Sun Island. This is in Florida. The entire bridge is 8 spans, 335 feet. And we were tasked with replacing the center 2 spans, which are shown in this picture. And primarily these spans have deteriorated. The bridge is only 25 years old. And you have jet skis that run under the bridge, and the fantail from the jet skis on the underside of the structure has caused significant deterioration. These are carbon steel reinforced precast sections, pretension and precast, and they didn't really stand up to the salt environment. So what the solution is to go with the G-beam and modularize it into precast segments. And as you can see, we're proceeding with that project as well. This is the G-beams being delivered to the Sun Island project, and we put all the G-beams on one truck, one trip, which certainly reduces transportation as far as what you would normally see. They are going to cast the precast decks on site and then lift them into place. This is going to be a really nice project to showcase the use of the technology, and this is a project we are using the composite bolts for reinforcement and the ridges. It will be monitored over time. So, where is the technology going? What's the future? What we're seeing is we have multiple projects right now that are in our pipeline, that are under design, that we're seeing a lot of interest. And there's certainly more continuous improvement that can be done to the system, and efficiencies that can be gained. But everything we've heard, all the feedback that we've gotten from other engineering consulting firms, as well as contractors, are especially interested in this, because if you notice in the picture there, actually putting these 75-foot girders in place is a relatively simple chore in terms of the lifting, and using a lot lighter equipment than they would traditionally use with heavy precast segments or even girders. And we've found a lot of interest out on the West Coast, as well as continuing New England and certainly within Florida. So we believe a huge spike in demand is coming up. So conclusion, the FRP is easier to ship and certainly lightweight, big advantage. Corrosion resistant, big advantage. Anything close to marine waterways, corrosive environments in general, this would be the go-to material. The application of FRP and infrastructure around the country, we're seeing significant interest and significant projects coming through the pipeline. And I think that with the, the real push at all levels of government in terms of sustainability and resilience, I think you'll see that use of the technology will continue to increase. And with that, we'll open it up to questions. Thank you very much.